When you put demands on systems, they are either designed to fail safely or they crash and burn. Take the electrics in my kitchen, for example. If I keep plugging more and more high-powered appliances into this trailer socket and then power them on, this wiring might catch fire. Alternatively, a better design would be that I pop the circuit breaker that engineers have sensibly added to my home and not burn the place to the ground. We can apply this exact same principle to our software applications using a pattern popularized by Michael Nygaard in his book Release It, the circuit breaker pattern. So what exactly does the circuit breaker pattern do? Well, for example, let's say we have service A making requests to service B, and these requests are covered by a circuit breaker policy. If all is going well, then the circuit is closed. If service B starts to slow down or even stop responding altogether, then the circuit will be open. This means that no more requests will be sent from service A to service B. After a defined amount of time, the circuit will move to a half-open state, allowing just one request through to service B. We can think of this as a little test to see if the service is ready to go again. If the request fails, the circuit reopens fully, ceasing requests for another period of time. It's common that each retry cycle waits for double the time. But if it's successful, the circuit closes and everything starts working again as usual. This is something that could be complicated to implement yourself, but it's relatively easy to add to your .NET project using the Poly project. The Poly project is a zero-dependency, lightweight library for .NET. It provides a comprehensive collection of resilience strategies that are easy to use. This awesome chart found on the Poly website shows you the different strategies, and it actually gives you this helpful AKA column. I really like this and wish more libraries included it. The most common example of Poly you'll see in .NET is with an HTTP client, and we'll cover that later in the video. But you can use Poly anywhere in your application. Basically, anywhere that you want to improve the resiliency of your app and robustly handle failures is a place where you can add a circuit breaker policy. Let's implement one. I have created a basic .NET 7 console application. In it, I have a class that returns a message 50% of the time, and the rest of the time it throws an exception. Now, I know that this example is somewhat contrived, but imagine instead that we're talking about something like a call to a database or maybe disk storage. These activities are prone to transient errors and performance issues. These are situations that not only frustrate your users, but make it harder for us as developers to diagnose and debug. Okay. In the program file, we are going to call the request message until we get a successful response. I'm doing this by setting a bool called isSuccessful, and then repeatedly calling the unreliable method in the pesky message class in a do-while loop. Let's add a circuit breaker to our logic so we can better deal with this flaky code. I've already added the Poly NuGet package to the project, so we're ready to go. In the program file, add a new variable of type async circuit breaker policy and call it circuit breaker policy. We want to be able to handle an exception, so define this as policy.handle type of exception, open close parentheses. We can then define the circuit breaker policy by chaining it to the policy definition. There are 6 overloads for this method, the most basic one being this one, where we state the number of exceptions to allow before the policy kicks in, and the duration of the break before the circuit moves to the half open state. Next, we're going to execute that pesky message code using this policy. On the circuit breaker policy, we call execute async of type string, as string is the return type of the method we want to call. Then, inside these parentheses, we create an anonymous async function, which calls the pesky message get method and returns its response. Now, when we run this code, it doesn't look any different, but if we log the circuit state using the circuit state property on the circuit breaker policy before and after the method call, we'll be able to see what the circuit is up to. On a successful call, the circuit stays closed, but on an unsuccessful call, we can see that the circuit is now open and we get the message not allowing any calls. If the request fails, it opens again, but if it doesn't, the circuit closes and the code completes. Straight away, you can see that we're preventing a failure state from constantly bombarding a system that seems to be experiencing unexpected difficulties. If we combine this with some other policies, such as handling retries and fallbacks, we're making a much more resilient system. Next, let's look at one of the most common implementations of the circuit breaker pattern, one that's used to make HTTP requests more resilient. We'll use a NuGet package from Microsoft that applies poly policies via an extension method on iHTTP Client Builder. This means we can add policies directly to both named and strongly typed HTTP clients. We can't, however, use this directly on the generic HTTP client because in this default form, with no arguments, add HTTP client returns an iService collection and not an iHTTP client builder. Let's go take a look. I have a basic .NET 7 Web API project with a minimal API endpoint. This endpoint has a dependency on the strongly typed HTTP client waffle service. The waffle service has a method on it called get. This makes an HTTP call to a very unreliable ingredient service. Wow, I have a lot of flaky services in my application. This seems like a great place to add some resiliency. To make the code easier to read, I've created an extension method on iService collection and added the HTTP clients there. If we run this now, we can see that sometimes we get a response and sometimes we don't. When we don't get a successful HTTP 200 response, the user instead receives an HTTP 500 error response, and there is a risk that this may be impacting the overall system. Let's add a circuit breaker policy to deal with this better. We are going to create a public static read-only async circuit breaker policy of type HTTP response message. We'll call that circuit breaker policy. This is almost identical to the code we wrote earlier in the console app. We then define the policy as policy.handleResult of type HTTP response message. You can see that this is going to fit our scenario quite well. We know that we are getting an HTTP 500 error, so let's tailor the policy to that. Inside the parentheses, we have a lambda expression with the input parameter message, and then when the message status code is equal to internal server error, we will execute the policy. We previously used the most basic method overload of async circuit breaker policy, so let's try a more elaborate one. We can add an action of onBreak, onReset, and onHalfOpen, giving us more fine-grained control over each stage. In these actions, I've added a console.writeLine so we can see what's going on at each stage. We then add this policy to the HTTP client waffle service by calling the addPolicyHandler extension method, with the circuit breaker policy as its argument, like this. Let's run it and see what happens. Cool, you can see that if the request is successful, everything works as expected. However, if the request fails for our specified 3 times, we can see that the circuit breaker pops open, and we can't make any further requests until it's in the half open state. If everything is okay when it's half open, then the requests continue as normal. Otherwise, it reopens and waits once again. We quickly and easily added that to our code, and if we were to combine it with a retry policy, the user would have a much better experience. For one, the user wouldn't have to keep pressing refresh and may be completely unaware of the underlying issues. I hope you've enjoyed this video and that you now feel better equipped to tackle some of your own pesky code problems. Let me know your thoughts and opinions in the comments down below. Thanks for watching, and I'll see you next time. Bye!